All right, hello everyone. We're working on Module 5, Java Programming, CS187, Grants, New Mexico for NMSU grants. Before we get started, are there any questions that we'd like to discuss concerning about anything Java related? If so, just go ahead and shoot a message in the chat. So last week we wrote a sample program, converted weight to Earth weight to weight on other planets, Moon, Mars, and Jupiter, I believe. And so you got to see how to use the same variable, how to write a simple program. Hopefully you're starting to think Java and not the kind you can drink, because I know that obviously a couple of you definitely think Java the kind you can drink. Well, what we want to do is we want to condition ourselves to think top down, but also using objects. Okay, let's see here. Can I explain the difference between print line and import system out? Okay, all right. So, Michelle, the question is, let me read it one more time. The difference between system out.println and the import system out and out println. They're the same thing. So hopefully that doesn't confuse you even more. Let me go ahead and we're going to switch over to screen sharing real quick, and we'll look at that. Here we go. Okay, so let's go ahead and go to Eclipse real quick. Oops, hold on. Wrong one. Okay, here we go. So on our textbook, let's go ahead and create a new class real quick, CS187. We're going to go to source, new class. This will be com.smithz. It's kind of hard to type around a microphone. And I believe this is 5. Oops, sorry, forgot to create the package. It's been a long weekend. Try this again. Can't even spell my own name. New package for chapter 5. Now we'll create our class, and we're just going to call this one practice today. Okay, so what we do is typically what we had been working with is this style right here, and we import the Java util.scanner class. In the textbook, he uses a shorthand, and he imports the whole system .out and the system .in, so that ultimately you can leave out the system when you type it right here. And so before you had autocomplete, you were able to reduce your keystrokes by 7 each time you needed to print a statement. Now that we use Eclipse and we have the SYSOUT that prints all of this for you, it's easier to follow this protocol, this syntax right here for the system out print line. Both are the same thing. And so you can either use the format in the book, and let's see, I'm going to stop sharing for a second and grab the book and look at it real quick. Let's see here. And I'm not sure what page we are looking at. Let's see here. Chapter 5 looks like about... Okay, so let me go ahead and share this screen as well. And so we're looking at it here. Let's try in the 70s. Get us pretty close. Let's see if we can find an example. Okay, so here's a perfect example. So here he's imported static Java language system out, and then here he just uses out.print. And that is the end result is the same thing, just we are being more specific with our import class and allowing us to need less when we're printing out a line. You can do it this way. It's really programmer's choice. I prefer the other way, mostly, especially if you're using Eclipse, because there's the shortcut to it. I just like to see the system.out. When I look at it, it helps me remember what's going on. It helps me focus on what I'm trying to accomplish. But either one is fine by me. Pick which one you like and stick to it. Did that help you out at all, Michelle? Okay. All right, so we're going to go ahead and tonight we're going to talk about Boolean and decision making. Now, the benefit to a computer, obviously, is it can think, sort of, if we give it the power. And the power is decision-based, and that decision-based typically comes in a series: switch case statements, if statement, do statements, while statements, and do while statements. That's pretty much the bulk of them. We're going to go over 3 tonight, and hopefully you'll get used to seeing them, and you'll begin to appreciate the power that is available to you when you make those decision statements. Because you can run a program like this right here, step by step, top to bottom, does exactly what you tell it to, but it doesn't allow us to really control our program. So that's what we're going to work on right now. Now, to get started, we do want some user input, but the first thing I recommend is to start commenting what you want. So first we're going to want user input. We don't know exactly what we're doing yet. We're going to kind of, as they say, wing it, but I'm sure we're going to want user input. We're also going to want to create a switch case statement. And let's say we're going to do months of the year, or a few of them, months of the year. We're going to do an if statement that will somehow work with the months of the year. And let's see, I'd like to go ahead and do a do while statement. And I don't know, we'll just do some kind of loop there, and probably, and we'll go ahead and do a while loop while we're at it. So this is going to be our starting format. So let's go ahead and go over this program from top to bottom. First, we have the original import, which was this when we created our class. Next, we went ahead and created our main statement here, public static void main. Remember, it has the string box, and those are called box brackets. The arguments, that's what that stands for, ARGS, and then our curly brackets. I want to sneeze again. Pardon me, I'm going to mute it. Maybe not. All right, back again. So then we have used some simple comments to start off what we're trying to accomplish. So the first thing that we do is we want some user input. So let's go ahead and create our scanner class. And that is scanner. Remember, I recommend that you use keyboard, something very specific, equals new scanner system.in, and Remember, each line ends with a semicolon. Now, notice here that it's turned red, and as its possible fixes, we need to import the scanner class, and that goes away. Now again, notice the yellow line under keyboard. That's telling us that it's not being used. If you look at the fixes, the first one says remove keyboard and all of its assignments. And that's because it's not being used, so it thinks it may be useless. So now we can gather information, but we do need a couple of more things. We need to have a statement to tell the user what we want to accomplish, and we're just going to say enter a number between 1 and 4. So now we have the ability to gather data. We now want to be able to store that data. So we're using whole numbers or integers, so we can go ahead and say int. We'll call this month, and then we don't we can do one of two things. We can either declare it and then come down here and gather it, but in keeping with simple coding, we want to go ahead and set that equal to our keyboard, and we want to get our next integer and semicolon. So now we've created the object that allows us to gather information from the keyboard. We've sent a message to our user, and now we have a way to store that information. So now let's look at a switch statement. And it's called a switch case statement right here. And what it means is, if this is entered, do this. And so I think it's easier just to look at it as we go along. So we call that a switch. Now we need to have the argument that we want it to use or evaluate. And so here we're taking the information entered by the keyboard that we called month. So we'll go ahead and put in month, if I can spell it. And next we'll put in curly brackets. Now notice that the yellow line and red line went away for month because now we're using it. Now the next thing we need to do is we need to give it a case. And a case is what exactly you want to evaluate. And it's spelled case. And in this case, we have the numbers 1, 2, 3, and 4, right? We told the user to enter one of those 4 numbers. So we will say case, if it equals 1. Now this is real important. When you're working inside of a case, the case selector is a colon, not a semicolon. Now we're going to tell it what we want it to do or say if the user input equals 1. And so we'll go ahead and just print out a message. And what does the month 1 correspond to? We're going to say the month is January, right? Now, the second thing that you must remember when dealing with case arguments is you must break. And after we type in the next one, I'll show you what that means. So we're going to do case again, and this time the next input possibility is a 2. So we say case, it's a 2. And you can think about it if you say, in case this, do that. Okay, so we're going to go ahead and say the month is February. Yeah, okay. And I'm going to go ahead and once again put a break in here. So let's go ahead and save this, Control S, and run it. Let me move you guys out of the way here. And so we're told to enter a number between 1 and 4. So let's go ahead and enter the number 1. So it says the month of January, which corresponds to 1. Now, what happens is when the code begins to run. It starts here. It says switch. Okay, takes the month. It finds the proper place for it. It will then do whatever you tell it inside here. If you have a break, it will then break out of this switch statement, which means it won't do anything else. So let's go ahead and comment this out real quick and save it one more time. And while we're at it, I don't like to come down to a second line. Let's get rid of that L in there so we'll be able to input on the same line as our text. So let's save that one more time, run, and we're going to put 1 in there again. Now, notice this time it says the month is January. It did not know to break out, so it came to the next one and says the month is February. Obviously, this is false. So you have to remember to include the break. There are a few exceptions of when you may want it to overrun from one case to the next. I don't know, you could write one that says if you enter 1, that prints an N. If you enter 2, it prints an M. And you want it to give the abbreviation for NMSU, you could avoid breaking out, and it would build all of them if they hit a 4, for instance. Something like that. Generally, you're going to want to break out of it. So let's go ahead and input, create our next 2 cases as well. Case 3, which is the month is March, my brother's birthday today. Create our break statement. Remember, a semicolon goes after every line except for the case. And we'll go ahead and do case 4. And I cannot, month is April. And let's go ahead. Now, we don't have to have a break here, conceptually, because if they enter a 4, there's nothing else that follows, right? But we're going to follow good programming habits and include that as well. And you'll see there is a benefit to that coming up. So let's go ahead and save it. Run it one more time. Now let's try a different number. Let's say 3. The month is March. So you can see how you can create a menu very easily, and it allows you to do mathematical formula. Anything you can write a code for, you can do inside here. You could call other classes, you could call methods, you could write formulas, whatever you need to do. Now, let's say that you enter this, and like typical human beings, I get a hold of it and I say, well, I want month 6. And I put it in there even though you told me 1 to 4. What happened? Notice it just goes dead. So in order to prevent that, or to be prepared for that, we have what's called default. And default is just that. If something happens outside of what you want, you can put that in there, and you can say, hey, dude, enter numbers 1 to 4. So now we've created a fail safe. So you get somebody that says, well, I want 58. No matter what, anything that is not one of these 4 numbers, it will automatically spit it out, and it gives them an alert. And so this can be very powerful, especially when you're dealing with usernames, or you're creating something where they need to be specific. Months of a year, there's only 12. So this gives you that ability to alert them should they have done something incorrect. So once again, I'm going to sneeze. So once again, this is a switch case statement. When you create a switch case, you use the reserved keyword, switch, whatever you want it to evaluate, in this case, month from our keyboard. We've given our case. Now, a good place where you use a char, for instance, and that's char, remember char, is here. So you may want to do a yes or no, for instance, and I'm going to leave that for you to practice with, but the method is the same. Switch, and you could say answer, case 1, or in this case would be Y, little y or big Y, or little no or little n or big N. Now let's look at this. You have the option of doing other items as well. So you can include other arguments in our case. I want you to experiment with it and find out how to do it. It's rather simple. It's just the addition right here. You're going to add one more thing, and that allows you to, like I said, have a little y or a big Y. So that way you only have to write one statement for it. You can take multiple inputs. But I'm going to leave that for you to work on as you're going along. Any questions on switch case statements? Okay. So next, we're going to deal with more Boolean style. And remember, a Boolean, B-O-O-L-E-A-N, is a reserved word, so it'll turn purple in Eclipse. And all of them, anything that's a Boolean question or a Boolean statement is either true or false. That's it. And so you can evaluate greater than or equal to, less than or equal to, equals, is or is not, and or. So you do have a few options. You're going to go through those, and hopefully you've already done those in math. You have a little bit of familiarity. If not, don't worry about it. But we're going to go ahead and do a couple. So the first one we want to do, according here, is our if statements. Now, if statements are really quite simple. If, the first part, now we have to set an argument. If what? In this case, we're going to work with our month still, and we're going to say if month is equal to, hold on, I'm going to sneeze again. Allergies are getting me. So, if month is equal to, now one thing to remind yourself of, in Java, a single equal really means you're assigning a value from the right side to the left side. And man, my finger's not working. Left side. And that's why we write it as month is equal to 1, for instance. 1 is being assigned to the variable month. When you're dealing with Boolean, you have the double equal, which means is exactly equal to. And so you can ask yourself, is 1 exactly equal to 2? And the answer is no. How about is 1 equal to 1.1? Once again, no. Remember, it means exactly equal to. And so what we're going to do is we're going to recreate this switch statement in an if statement so that you can see how both work, and you'll be able to determine which one you like. Often you have the choice, although an if statement tends to be used more because it does give you a little bit more user control. So we're going to say if month equals 1, put in our curly brackets, and we're going to go ahead and print something out. And since we already have January, we're just going to give it the abbreviation. Abbreviation is equal to January. So this says if month is equal to 1, print out January. Let's go ahead and test that real quick. Control S or save it, run it, hit 1, and so the first program starts top to bottom. It goes to the switch, says this month is January, correct. Goes down, now it goes to this if statement, and the abbreviation for January is JAN. All right, so that's working well. Now what do we do? So we know if we have a choice, if this, do that. But everything may not be month one, so we have to have a little bit more control. And that is followed by an else if. So if month one is equal to, or if month is equal to 1, do this. Else if, so what do you think goes here? Month is exactly equal to 2. We're going to then print out another statement. And hopefully you're already running this through your head. You should be ahead of me already. So we're going to say abbreviation equals February. But what if, don't like that. What if we do not input 1 or 2? Well, same thing again. Else if month is exactly equal to 3. And come over here and print it again. Don't forget your shortcuts. Make use of technology. March. And if it's not a 1, 2, or 3, 4, what do we have? Else if, again, month is exactly equal to 4. And again, April. I think that's the abbreviation for April. So let's go ahead and test this real quick. Save it, run it. Let's go ahead and try 3. So what should we get? Take a second, think it through, state your answer. Now let's test it. If you said the month is March and the abbreviation is MAR, you're correct, or at least you're as off as the computer. One of the two. Either way, I'm happy with it. So we have one more thing left, and that's this default. Because if we run it and they input 9, so this one says, hey dude, enter the right number, but this if statement does nothing because these are exactly equal to. Well, we cancel it out with an else, a final else. So if it's not 1 or 2 or 3 or 4, do this. And so we'll go ahead and do a sys out here and say, get a grip, man. All right, he's not paying attention to what's going on. So now we can try it one more time. Let's try 5. Enter a number between them 4 and get a grip. So here you've seen exactly equals 2. I want to go ahead and do another if statement that works a little bit different, and this is going to evaluate a greater than. So let's say if month is less than or equal to, well, we live in New Mexico. Well, some of us do. I don't know about the weather in Okinawa, but in New Mexico, we'll say anything that is less than or equal to 3, which is March, we're going to go ahead and print a statement that says, wear a jacket. Not exactly true, but we're going to pretend it is. Else, we're going to say, wear shorts. So now, hopefully, when we run it and we enter a 2, we should get the month is February. Its abbreviation is FEB, and it should tell us to wear a jacket. Let's go ahead and test that. All right, we're going to try 2. Voila! Month is February, abbreviation, and wear a jacket. So now you have the ability to start to allow the computer to make decisions based on the parameters that you give it. Now, so what happens if we run it and we input 3? Take a second. Is that what you expected? Wear a jacket. And you should have, because we said month is less than or equal to 3. So that would mean in this case 1, 2, and 3, it is wear a jacket. If we run it one more time and we enter a 4, should tell us to wear shorts, which it did. Okay. Any questions on that? I'm going to hydrate. Okay. Now we have what's called a do while. Now, we have an if statement says, if this is true, do this. A do while, and you notice it's do and while, means quite similar. Do this while this is true. So we're going to do a little bit of a different. We're going to say, we're going to create an integer, and we're just going to call it number. And we're going to start that number at a number. We'll just pick 3. Sounds good to me. Now, we want to do something while something else is true. This is what we're trying to accomplish. So first, what are we going to do? Well, we're going to print something out. We have a number there. So let's just go ahead and say, your number is equal to. Okay, that's a good starting spot. And now, while it is true. So we're going to use a Boolean, which means we have to come up with a true or false. So we could say, while number is exactly equal to 3, do this. And let's go ahead and save it, run it. We'll pick our month because we have all that in there. Woo-wee! Now, look at what we have going on here. I'm going to move this because I don't know if you can see it or not. Look at what's going on. See that thing going? What's it doing? Notice it's getting smaller and smaller. This is a crash. And in fact, it's going to crash so good, I'm going to have to stop sharing so that I can kill the program and reopen it. All right, so let me go back and reopen Eclipse real quick. So what happened? We did not give it a true or false ability to stop. In this case, our number was equal to 3. Let me get back to our screen share here real quick. We're loaded up again. Okay, here we are. So, our number was 3. And we said, print this while this is true. And as you saw, it would be true to infinity. So if I didn't crash it, it just would have went on forever. Or at least as long as it had a way to continue. So do while loops can seriously bug up your day if you do not make a way for them to be false. And this is really important. So what we're going to do, we're going to modify this a little bit. Let's go ahead and concatenate our number in here. And so we'll do that with a plus sign and then type our variable name. Now we're going to set a system that will allow us to make a false statement. So this will continue because as long as this is true, it will go on forever. The easiest way is to add a counter system. And you can do that by saying number is equal to number plus 1. Now, what it's going to do is it's going to start here. It's going to print this line. It's going to come down here and it's going to say number, which was 3, plus 1 is 4. When it gets to here, it's not going to run. So let's test that real quick. Let's save it, run, enter something here. So our number is equal to 3. Now let's think this through. I'm trying to move this chat box. I don't know if you guys can see it or not, but it's aggravating me. Okay, so we set our integer to 3. We came to here. It said, do this. Your number is 3. While then it changes the number, which this would become a 4. And now, while this number is 3, so when it comes back again, next time it's going to be 4 because we added 1 to it. It's no longer true. It's going to stop. So let's change this a little bit. In Java, there's a couple of shorthands to make this statement easier, and you will use it a bazillion times. So just learn it now and save yourself a lot of hassle. And that is the plus plus. This does exactly what we had just did with number equals number plus 1. And this is a shorthand that you'll use a lot. So get used to this format. You can also subtract a number if you did minus minus. You can times a number, but that gets kind of pointless because it'd be astronomical in no time. But this is called an incremental counter. And so this increments by 1. Nice and simple. Now, to validate that, let's go ahead and say we want it to print this number is equal to, for anything that is less than or equal to 20. And let's go ahead and change this to 0 so we can watch it count. And to avoid a lot of redundancy in this, I'm going to come up here and comment this out. Remember, when you comment something out, it stays there. It just removes it from the compiler. So let's save this and let's run. Oops, and I forgot to comment out this as well. Okay, save this and run. So our number is equal to 0. Equal to 0. It went through, printed 0. It added 1 to itself. It changed this value here to 1. And you notice it went down through 20. So this has a lot of potential. And you will use this system of incrementing and printing constantly. You may use a mathematical formula, say you're doing Fibonacci numbers, or you just wanted to count even numbers or something. You can use this in an awful lot of ways. So now you see that we can print our number, add 1 to it, it will then evaluate it, and as long as that's true, it will continue to go. Now, yes, if you're wondering, if we change it to 200, do the same thing, yep, it's going to keep going. So now we have provided it a true or false statement. When it is greater than 200, kicks itself out and stops. This is really powerful. Always, always, always remember to put a false statement option so that it will terminate. Otherwise, it will go on forever. You have to kill your machine. If you were practicing bad programming habits and not saving regularly, you just lost all your work. Okay, so any questions on that? All right, well, now we're going to move on to a while loop. And a while loop is quite similar. However, it processes, in essence, backwards from the do while loop. So, best way to learn, let's code it. So we'll go ahead and say while. Now we need a Boolean test. We're going to go ahead, let's see, we'll just stick with number since we've used it up there. And we're going to say while number is less than 20, right? We're going to come over here, put in our curly braces, and now we need to tell it what to do. I'm going to go ahead and print something else, and we're going to say and this is equal to, we want to go ahead and concatenate our number. Yes, it's a mouthful. And we're using number again. Again, how do we control a while loop? The same way that we control a do while loop. We need it to count up so that this eventually becomes false. Otherwise, it'll go on forever. How do we do that? So number plus plus, and of course our semicolon. You could also do number plus equals 1, or you could do number is equal to number plus 1. Your choice. I recommend the plus plus. You could do it differently if you like, but I'm sticking with plus plus. So now we have a while loop. So we're going to go ahead and change this. Now, let's look at good programming principles. Notice we have a variable here, and we have a hard-coded variable here. Is it okay for these to be the same thing? In this instance, it probably is. So we're just going to create us another integer, and we're just going to call it loop value. And that way we can change it here, and we won't have to manually change it here. One of the great things about programming is it gives you, if you have a little bit of creativity, that's about all I have, but it does give you the ability to experiment. So let's say that we wanted to have a whole series and these are going to be twice as much. Well, could we do loop times 2? So what do you think? Is this going to make this 40? Well, let's try it. Try it. What's the most that will happen? It breaks. No big deal. So let's look at it. Your number is equal to 20. And it went all the way to 40. So this part is good. Now, let's look at this one. What happened here? Why didn't it print? Test it. Test an idea. Does the less than or equal to make a difference? Part of solving problems is recognizing that you have to experiment. And notice we're still getting a problem here. So let's go ahead and comment this out and see if in fact it's even running. Okay, so it is running, right? Just hiding out down there in the bottom somewhere. So we have now used a single variable and we have modified it in 2 different ways in order to give us 2 different outputs. And we've even had to bug check a little bit to see what's going on here. Let's go ahead and save this one more time. Your number is equal to. So let's look at this for a minute. Notice we're using this same number right here. This number is this number. So when it reaches here, number is greater, less than, or equal to loop value times 2, which we've declared as 40 now. When it gets to here, it says, hey, if number is less than loop value, print it out. Well, when it gets done here, what's our number value? It is 40. So it makes sense that this one will not run because it's being closed out because this one has already set the value too high for this one. So let's try this. Let's say, what if our number is number minus 40? Theoretically, that should be what? Number minus 40 should be 0 because this value sets it to 40, right? Let's try that. Aha, problem solved. This comes down here. But notice that our value is still starting at 40 because it's printing our number, which in fact was number equals 40 when it gets here. So it gives us the next 20 in line. So as you can see, sometimes you have to be really cautious about how you're using variables. So obviously the best method here would be to either use separate numbers, or if we needed it to print from 0, we could say, again, we could go ahead and say int number equals 0 if we wanted. And it's going to throw up this complaint because it's going to say, hey, wait a minute, you already are using that. What do you want to do? And so you would have to then get a little bit creative with it. I would recommend that we not use that. Now what you could do is incorporate an if statement. Okay, so let's say if number is equal to or greater than 40. Hello. I don't want that. Oh no. Well, hold on one second, guys. Trying to type around the keyboard and okay. And we need to turn on console real quick. So don't worry if you accidentally close something out. We'll leave this one on the bottom for now. So here we can say if number is equal to or greater than 40, then number is equal to, boy, it's going slow. Probably because I have that other one. I'm going to stop sharing for 1 second and close that out. Okay. And we're back to sharing again. Okay. So now we can go ahead and set number is equal to 0. And notice that we continually are picking up error after error. These are not permanent errors, but it is telling you that you're starting to get things confusing. But we're going to go ahead and work with this. Number is equal to 0. We do this. Eventually, the number value becomes 40. It says if number is equal to 40, set number to 0, and then we come down here and run this. So let's go ahead and save it, and let's see if it runs the way we want it to. Okay. Let me expand this up here. All right, so we have the number is equal to 40, and once again, we're getting stuck in this continual system of number equaling becoming. And so when you come across situations like this, and it will happen constantly, do yourself a favor and improve your variable keeping system. Stay away from as many of these redundancies as you can. The simplest solution is not to write a new if statement or to create a whole new series of stuff. The simplest solution is to make a new int that does not rely on all of this mathematical processing. And this way, you can keep everything straight. Unfortunately, this is not something that's taught enough, and you will find many examples in books where they'll use the same number over and over and over, and it can get really burdensome really quick. So here we can go ahead and switch that to number 2, that to number 2, and that to number 2. And now let's save it and run, and now we have a nice clean output. Your number is equal to 1 to 40, and our number is equal from 0 to 20. Excuse me, from 0 to 40 and from 0 to 20. So little things like that can make a whole lot of difference in how your program works, how easy it is to be read by somebody else, and how easy it is for you to find bugs in your own system. So, unless we have any questions, I think it'll be about time to wrap it up. I'll go ahead and give it a minute here. Let's see. Well, I don't see any popping up. We still have a couple of minutes. Apparently, to keep this able to upload into Canvas, I have to keep it under 54 minutes and 15 seconds, or we blow our capacity and will no longer upload there. Anything from you, Michelle? All right. Well, sounds good. All right. Well, thank you for joining this code and chat. I hope it's been helpful to you. This next chapter allows you to really start to use your programming abilities and to start creating stuff. From this chapter forward, you're going to be making things that work. And that, to me, is always the best part. So thank you for attending. If you have any questions, as always, shoot me a message. If you see anything that you need a special little video on, let me know as soon as possible, and I will also get that up. Otherwise, I'd like to thank everybody for showing up, and have a great day, great evening, and we'll talk to you soon. All righty. Bye-bye.